On November 15th, 2025, astronomer Tirasak Thaluang from Thailand captured an image using a 0.26-meter telescope that has the scientific community in absolute chaos. We're talking about jets extending over 1 million kilometers into space, maintaining perfect orientation despite the comet's rotation, defying every model of natural comet behavior we've ever established. And man, things just got even stranger since perihelion. We're dealing with structures that shouldn't exist, physics that doesn't add up, and a timeline of anomalies that now stretches to 12 distinct mysteries. Let's get straight to what matters. On October 29th, 2025, when 3I Atlas reached its closest point to the Sun at just 1.4 astronomical units, that's inside the orbit of Mars, something extraordinary began happening. The comet emerged from solar conjunction, displaying features that have astrophysicists scrambling to explain. Multiple observatories across the globe recorded data that conflicts with everything we understand about cometary mechanics. The Thailand observation revealed tightly collimated jets, razor-sharp streams of material shooting outward with surgical precision, maintaining their structural integrity across distances where they absolutely should have dissolved into chaos. And here we reach the moment of truth, folks. According to observations compiled between July and November 2025, 3I Atlas rotates every 16.16 hours. That's established fact. The NASA Hubble Space Telescope, the James Webb Space Telescope, and the European Space Agency's Mars orbiters all confirm this rotation period. But here's what makes no sense whatsoever. Those jets captured by Thaluang on November 15th extend more than 1 million kilometers. At the expected thermal speed of sublimated volatiles from a natural comet, roughly 400 meters per second, it takes approximately 1 month for material to traverse that distance. Now ask yourself this question. How could these jets possibly maintain their precise orientation if the comet is spinning around every 16 hours? The mathematics simply does not work. Let me put this in perspective. Imagine a garden sprinkler rotating on your lawn. The water streams create arcs, spreading patterns across the grass because the source is spinning. That's basic physics. That's what should happen with 3I Atlas. But instead, what we're seeing is the equivalent of that sprinkler creating laser straight lines, extending to the next city block, completely ignoring the fact that it's rotating. Harvard astrophysicist Avi Loeb, who has been meticulously documenting every anomaly associated with this object, has now catalogued this as the 12th mystery on his list. 12 unexplained phenomena from a single interstellar visitor, the statistical probability of natural explanations accounting for all 12 simultaneously, is approaching zero. And that's when everything changed. First anomaly, impossible trajectory alignment. The retrograde orbital path of 3I Atlas aligns to within 5 degrees of the ecliptic plane. For an object arriving from interstellar space, the probability of this alignment is 0.2%. Think about throwing a dart at a sphere from across a football field and hitting a target the size of a quarter. Natural objects don't arrive with this precision. Second anomaly, the sunward anti-tail. Between July and August 2025, and again in early November, 3I Atlas displayed a prominent jet pointing directly toward the Sun. Multiple observatories, including the European Space Agency's ExoMars Trace Gas Orbiter, observing from Mars orbit, confirmed this is a real physical structure. Material is somehow being ejected toward the Sun, against the force of radiation pressure that should be pushing everything away. David Jewett and his collaborators suggested this might involve giant dust particles, 1 million times more massive than typical comet dust. But even this explanation struggles to account for the observed morphology. Third anomaly, mass and velocity combination. The nucleus of 3I Atlas is approximately 1 million times more massive than 1I Oumuamua, and roughly 1,000 times more massive than 2I Borisov. At the same time, it's traveling faster than both previous interstellar visitors, reaching speeds of 250,000 kilometers per hour. The likelihood of an interstellar object having both exceptional mass and exceptional velocity is less than 0.1%. Fourth anomaly, arrival time, fine-tuning. The trajectory was perfectly calibrated to bring it within tens of millions of kilometers of Mars, Venus, and Jupiter, while remaining unobservable from Earth at perihelion due to the Sun's glare. The comet passed closest to Mars on October 3rd at just 29 million kilometers. Then it emerged in early December, precisely when Earth-based telescopes could resume observations. The probability of this timing, 0.005%, 1 in 20,000. Fifth anomaly, retrograde jets maintaining coherence. Those million-kilometer jets aren't just long. They're coherent. They maintain structural definition across distances where thermal expansion and radiation pressure should have scattered the material. Eric Cato and Avi Loeb proposed these might be ice fragments or technological thrusters, producing tightly collimated outflows, with speeds exceeding several kilometers per second. But here's the crucial point. The jets aren't just coherent. They're stable in orientation, despite confirmed rotation. On November 9th, F. Niebling and M. Buchner captured detailed imagery showing this phenomenon. There's no mechanism in standard cometary physics to explain it. The jets should smear. They don't. And that, my friends, changes everything. Sixth, anomaly, coma color evolution. Throughout July 2025, the coma grew progressively redder. A study by Tony Santana Ross documented this color shift. But the rate of change didn't match thermal models, predicting how ice sublimation should alter surface chemistry. The comet was changing faster than standard warming models predicted. Seventh anomaly, emission spectrum complexity. When the James Webb Space Telescope analyzed 3I Atlas in late August, it detected carbon dioxide, water, carbon monoxide, carbonyl sulfide, and water ice all being released simultaneously. The Very Large Telescope added cyanide gas and atomic nickel vapor. The relative abundances don't match any known class of comet from the Oort cloud or Kuiper belt. The chemical fingerprint is unique. Eighth anomaly, nucleus size uncertainty. NASA's Hubble Space Telescope observations indicated the nucleus could be anywhere from 440 meters to 5.6 kilometers in diameter. That's a tenfold uncertainty range. With 3I Atlas, the nucleus light can't be separated cleanly from the coma's light, even with Hubble's resolution. The coma is too dense, too active, and too persistent. Ninth anomaly, discovery timing and galactic center alignment. Amateur astronomer Sam Dean noted that 3I Atlas likely escaped earlier detection because it was passing in front of the galactic center's dense star fields during May and early June. The trajectory carried the object through the most difficult observational region at the exact time when early detection would have been most valuable. 10th anomaly, non-gravitational acceleration. Data submitted to the Minor Planet Center shows slight deviations from a purely gravitational trajectory, but the magnitude and direction don't align perfectly with the observed jets and outgassing rates. The comet is accelerating in ways that can't be fully explained by visible activity. 11th anomaly, pre-discovery observations spanning multiple telescopes. The Asteroid Terrestrial Impact Last Alert System, the Zwicky Transient Facility, and multiple amateur observatories all captured images before July 1st. When researchers went back through the archives, they found unusual brightness fluctuations that don't match standard rotation models. 12th anomaly, the persistent jets documented by Thailand. Thirasak Thalawang's November 15th observation captured what Avi Loeb now calls the crown jewel of anomalies. Jets extending over 1 million kilometers, perfect collimation, stable orientation, no rotation smearing, no thermal spreading. And here's what makes this so significant. The observation came after perihelion, when cometary activity should be declining. Instead, 3I Atlas displayed the most structured, organized, and physics-defying morphology of its entire transit. According to the European Space Agency, 3I Atlas traveled at approximately 250,000 kilometers per hour during closest approach, the highest speed ever recorded for any solar system visitor. That velocity suggests the object has been drifting through space for billions of years. If it originated from the Milky Way's thick disk, 3I Atlas could be older than our solar system itself, 7 billion years of traveling through the galaxy, and it arrives here, now. With this combination of impossible features, NASA assembled an unprecedented observational campaign. Hubble, Webb, the Transiting Exoplanets Survey Satellite, Mars rovers Perseverance and Curiosity, Mars Reconnaissance Orbiter, Europa Clipper, Parker Solar Probe, and the European Space Agency's Solar and Heliospheric Observatory. Never before has the entire infrastructure of space-based astronomy, focused so intensely on a single target. The National Aeronautics and Space Administration stated that 3I Atlas poses no threat to Earth, remaining at a minimum distance of 1.8 astronomical units. The closest approach to our planet occurs on December 19th, 2025. But the question isn't about danger. The question is about comprehension. What are we looking at? Harvard astrophysicist Avi Loeb doesn't rush to conclusions. He emphasizes scientific rigor. He's not saying this is alien technology, but he is saying the Loeb scale, his own metric for assessing the likelihood of technological origins, currently ranks 3I Atlas at a 4 out of 10. That's higher than 1I Oumuamua ever reached. Loeb has stated publicly that if upcoming spectroscopic measurements reveal outflow speeds exceeding several kilometers per second, inconsistent with natural warming and sublimation, he will increase that ranking. If new objects near Earth or Mars are discovered and linked to 3I Atlas, the ranking reaches 10. Maximum. We're watching this unfold in real time. The comet is now moving away from the Sun, headed back into interstellar space on an unbound, hyperbolic trajectory. It will never return. By March 2026, 3I Atlas will cross back beyond the orbit of Jupiter and fade from view forever. Every observation we make in these coming weeks represents humanity's only chance to understand what passed through our cosmic neighborhood. The implications stretch far beyond astronomy. If 3I Atlas is a natural object, then our models of cometry physics require fundamental revision. We don't understand ice sublimation. We don't understand dust-particle dynamics. We don't understand rotation mechanics. Entire textbooks need rewriting. But if the alternative proves correct, if some percentage of these anomalies point toward non-natural origins, then we're witnessing humanity's first documented encounter with technology from beyond our solar system, not radio signals. Physical hardware traveling through space. Galileo looked through his telescope 415 years ago and saw moons orbiting Jupiter, proving Earth wasn't the center of everything. Einstein showed us that space and time bend around massive objects. We stand now at another threshold, holding instruments capable of testing hypotheses our ancestors couldn't even formulate. 3I Atlas is a mirror held to our understanding of the cosmos, reflecting back questions we didn't know we needed to ask. So, what do you all think about this story? Natural phenomenon defying our current models? Technological artifact from an alien civilization? Or something entirely beyond our current framework of understanding? Leave your theories in the comments, and if you want to follow every update in this saga, subscribe to the channel because December 19th, 2025, when 3I Atlas makes its closest approach to Earth, promises to be epic. Additional spectroscopic data should be released before the end of November, and those measurements might give us the definitive answer about outflow speeds and material composition. See you next time.